In this video, we're going to talk about angles and their measures. There are a lot of vocabulary terms in this section that we want to review, as well as get used to working with different types of angles. And so we'll go through that as we introduce trigonometry. Remember, trigonometry is the study of the properties of triangles. And so we get some very nice properties. Of course, this is pre-cal, and so we're going to get into functions that are called trigonometric functions. And so once we get used to angles and triangles, we'll be able to definitely, in the unit circle, we'll definitely be able to get to trigonometric functions and add some additional functions to our repertoire, our library of functions. The first definition that we want to review is the definition of a term called a ray. A ray can be thought of as a half of a line. Remember, a full line is straight and extends indefinitely in two directions, two opposing directions. And so a half line is just taking half of that line away, which means you're going to have a starting point and you're just going to extend indefinitely in one direction. A ray is important because an angle consists of two rays that actually share a common point, and that common point is called the vertex. And so an angle would be an example that looks like this. Now, with an angle, we usually notate the rotation from one ray to the next. We have to identify one ray, the initial side, as the initial side, or the initial ray. We usually use the word side, and this is the terminal side of this angle. And so the rotation that allows me to get from this initial side to this terminal side is going to be important because that's how we measure angles. And so notice they share this common point here, which we call the vertex. Okay, so two rays together. One is going to be called the initial side. The other is going to be called the terminal side. That creates what we call an angle. A central angle is an angle with its vertex at the center of a circle, right? And so remember, your circle consists of all of the points that are equidistant from your point, which you call the center. And so we can put an angle within that circle with this is the center of our circle here. And once we put the angle with the vertex at the center of the circle, we just call that a central angle. We're placing the angle within the circle. So the vertex is actually at the center of the circle. An angle can also be placed within your XY plane, right? So that we can think about numbers and values, because what we're going to be doing is looking at trigonometric functions, which is going to be in our XY plane. But before we do that, we can think about an angle in standard position. And this is very important for the unit circle. And basically standard position is when your angle's vertex is at the origin and the initial side is on your positive x-axis, right? And so any angle that I draw that looks like this would be an angle in standard position, right? So my center is at the origin, my initial side is at the positive x-axis. That is what we call standard position. We measure angles by using several different units. We're going to talk about two in this course, but there's the degree measure of an angle, and that it basically represents the amount of rotation from the initial side of that angle to the terminal side of that angle, right? And it's going to be given in degree units. One of the things that we want to know is that one full revolution consists of 360 degrees, right? And so if I have an angle, whether it's a central angle, it's in standard position, or what have you, one full revolution that gets me from my initial side all the way back to my terminal sides to where they lay on top of each other, basically, that's 360 degrees. And so we can basically divide 360 degrees into different segments, and then we can get all of our other angle measurements, right? But one full circle or one full revolution is considered 360 degrees, and all of my other angles can be subdivided. Their measures are subdivided by dividing 360 degrees by however much rotation that's going to represent. There's also vocabulary terms that we can use for angles that show up in geometry that you may remember. For instance, an acute angle is an angle whose measure is between, not including, but between 0 and 90 degrees. And so any acute angle will have a rotation that doesn't go all the way to 90 degrees, and that's not 0 degrees, right? A right angle is an angle whose degree measure is 90 degrees, and this is basically your corner of the angle made on squares and rectangles. Because if you divide your 360 degrees into 4 equal units, you're going to get like your 4 quadrants, and you're going to make a 90-degree angle. Of course, we usually put a little box there, a square there to represent that. An obtuse angle is any angle measured that's between 90 and 180 degrees, not including those values. And so it's going to be bigger than a 90 degree, but less than 180. So a measure like that, an angle that looks like that. And then a straight angle is an angle whose measure equals 180 degrees, and 180 degrees is half of 360. So I go a half of a circle, whereas your 90 degrees goes a fourth of a circle. And uh-oh, that doesn't look very straight, does it? We get something like that, right? That's 180 degrees. All right, so these angles are important. Again, the 90-degree angle is a fourth of a full rotation, so we get something that looks like a corner of a square of a rectangle. A straight angle is half of a 360-degree angle, so you go a half circle, and you get that angle there. The acute and obtuse, there are those values that are between those values. And so with that, there are some very important angles that you're going to want to know and memorize. And these angles are multiples of 30 degrees and 45 degrees. Of course, we say 60 degrees as well, but if it's a multiple of 30 degrees, it's also a multiple of 60. If it's a multiple of 60 degrees, it's also a multiple of 30 degrees. But basically, these angles are important. They have some very good properties that we'll see. Remember, these angles are, I actually have a central angle because this is a circle, and the vertex of these angles are at the center of that circle, but this is a central angle that's actually in standard position because the vertices of these angles are at the origin in our XY plane. And so our initial, notice this rotation here, this little arrow here, all of these angles have this rotation here. And so our initial side for all of these angles is our positive x-axis. And so this is a 30-degree angle. You add 15 to that, you get 45-degree angle. You add 15 to that, you get your 60-degree angle. All right. You add 30 to that, you get your 90-degree angle, right? That's your right angle, right? All of these angles have the initial side on the positive x-axis. And so these patterns here actually continue to follow in the other quadrants. For instance, this is always a 30-degree angle from my x-axis, and this 60-degree angle is always a 30-degree angle from my y-axis here. And so I've got to go 30 here to get to my next angle that's very similar to this 60-degree angle, but it's in this quadrant over here, so it has more rotation. That's a 120-degree angle. This one, add 15, right, because these are 15 units apart, I get 135 degrees. Add 15 to that, I get 150 degrees. And this one has a similar property that that 30-degree angle has, that is 30 degrees from your x-axis. And so this is going to be 30 degrees from my x-axis, which is 180 degrees. And that pattern is going to continue in all of my quadrants, right? I'm going to add 30 there. I'm going to get 210 degrees. Add 15, 225 degrees. Add 15, I get 240 degrees. Add 30, I get to 270 degrees. And by the way, this is 0 degrees. If my terminal side, and if I didn't do any rotation, my initial side is my terminal side, then that's 0 degrees, which is a 0-degree angle is possible. Or if I go one full revolution, we already said that that's 360 degrees. So notice these angles are all positive because they measure counterclockwise. That yields positive angles. So counterclockwise, we get positive degree measures. If we go in the opposite direction, we're going to get negative degree measures, and we're going to see that in just a few moments. All right, so you want to memorize all of these angles here. Definitely memorize these by the time you get to class. Memorize all of all of these angles within this circle. We also have coterminal angles. So notice if I went one full revolution, I get to 360 degrees. But you can go an angle, you can have an angle that goes beyond one revolution. Think about a tire in your car, right? If you keep driving, you're going to do multiple revolutions, right? And you may end up on an angle that's more than one revolution, right? And so we have what we call coterminal angles. And these are angles in standard position that have the same terminal side. Keyword coterminal, same terminal side. This means basically that their measures differ by a multiple of 360 degrees, right? And so if I have an angle called theta, right, then a coterminal angle to theta can be found by taking that theta and adding some multiple of 360 degrees, right? So I can say 360 degrees times some constant k, where k is an integer. And then we can get to more angles, right? For instance, in this example, it says find two positive and two negative angles coterminal with an angle whose measure is 35 degrees. Well, my angle here is 35 degrees. I'm going to find my two positive angles, right? Then what I could do is take that 35 degrees and I can add one revolution to that, right? Or 360 degrees times one, where I let this k, this constant here, be one. Well, that's 395 degrees. I can also add another 360 degrees, or I can use this formula here and let k equal 2. Well, 360 times 2 is 720, and so if I add 720 and 35, I'm going to get 755 degrees. All right, now that's a huge angle measure, but notice here, we said that they're coterminal angles, right? And so my 35-degree angle will be in this little angle here, right? All right, I'm estimating here, but the difference between having this and drawing a 395-degree angle is that I have to go one full revolution and get back, and that's how I would notate that. To get to a 755 degree, and I'm going to make this longer so that you can see, I have to go not only one revolution, but two revolutions and get back to that angle measure. And that would be my 755-degree angle. That's how I would draw it. We can find out our two negative angles. Maybe I don't need the word S. All right, the letter S. Well, for me to get a negative angle, then I can let my k be a negative number, and so I can add 360 degrees. I can let k equal -1. So that's basically subtracting 360 degrees, and I'll get a negative 325-degree angle, right? And then if I want another negative angle, then I can subtract another 360 degrees from that negative 325, or that's equivalent to letting k equal -2 here. So that's a negative 720 plus 35, I get negative 785 degrees. And so if I were to draw these two angles here, remember my 35-degree angle is here, for instance. Well, if I wanted a negative 325-degree angle and I'm in my XY plane, instead of my rotation going counterclockwise, I'm going to go clockwise from my positive x-axis, and a negative 325-degree angle will have the same coterminal side or the same terminal side, but the rotation, since it's negative, is in the opposite direction, right? And so that goes, I subtracted 360 degrees and I got to that point right there. Remember, this part right here is that 35 degrees that I started with. I go in the negative direction or clockwise. To get to that second negative, I not only have to go one full revolution back to my positive x-axis, but I'll go another full revolution to get to here. And it's not another full revolution since I'm going in the negative direction. All right. It is full revolutions from this terminal side, but I'm going to start here and go in that direction. So I started with my positive x-axis to get there. All right. So that introduces how we do negative angle measures. That's because the revolutions or the rotation can be in a clockwise manner. Some other terms that are related to your angles are what we call quadrantal angles. Those are angles whose terminal sides is on an axis. And so if I think about my XY plane, for instance, our 0-degree angle is on the axis, has its terminal side on an axis. Our 90-degree angle, 180-degree, 270-degree, and 360-degree angles are quadrantal angles. All right, so that's 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And they're coterminal angles, okay? But I'm only going to write those. Angles, if an angle is not a quadrantal angle, then its terminal side lies within a quadrant. So if it's not one of these angles, then we say that it lies in a quadrant. And so one of the things that's going to become important is the quadrant in which an angle lies. And so I want to identify the quadrant of these two angles here. We have a negative 110-degree angle. One of the things that you can do to help you out here is to draw your angles, your quadrantal angles, right? Now, this is a negative angle here, right? So what I'm going to do is I'm going to draw negative angles to help me figure this out. For instance, I know that this is 0 degrees, right? If the terminal side is on my positive x-axis, but I'm going to go in a clockwise manner. And when I go in a clockwise manner, this is actually going to be a negative 90 degrees because the rotation from here to here is a fourth of a revolution, which is 90 degrees. It's in the clockwise manner, so that's negative 90. If I go another one, I get to negative 180 degrees. Go another fourth, I get to negative 270 degrees. And if I go back over here, I'm going to get to negative 360 degrees. And so if I look at this angle here, now I'm going to erase this little explanation to that negative 90 degrees. If I look here, I'm trying to figure out which quadrant a negative 110 is in. Well, a negative 110 is between negative 90 and 180. So my angle may look something like that. And so I'm going to say it's in quadrant 3. Let's look at part B here. We have a 750-degree angle. Well, if you notice, that's bigger than one, it's positive first, right? So we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, right? Well, what I like to do when my angles are big, either a big positive number or a big negative number, is to find the coterminal angle that's between 0 and 360 so I can figure out which quadrant it lies, right? So what I'm going to do is I'm going to take off one revolution, which is 360 degrees, right? This is going to help me find my coterminal angle, right? So if I subtract 360 from that 750, I'm going to get 390 degrees, right? That meant I went one revolution, right? Well, this is still bigger than 360 degrees. So I'm going to subtract another 360 degrees and I'm going to get 30 degrees, right? So I have to go not one revolution get me to 360, 2 revolutions get me to 720, and then I need to go up to get to this coterminal angle, which is 30 degrees. And so my angle would look like that, right? So this is a 720-degree angle. It has a 30-degree angle as its coterminal angle, but finding that 30 degrees allowed me to find which quadrant, which we're trying to find here. And so I'm going to say quadrant 1. And so what we want you to be able to do is to draw any angle, and you can use the fact that you know your quadrantal angles, you know how to go to draw positive and negative angles, and that you'll be able to identify the quadrants in which your angles lie in as well. Not only can we measure angles using degrees, we can also measure angles using radians. Radian measures are based on central angles that intersect the unit circle. All right, anytime we use unit in math, if we're not saying just give you units, but if we call an object the unit object, it basically represents the number 1, right? And so when we say the unit circle is a circle with a radius that's equal to 1. To find the radian measure of an angle in standard position, we find the length of the arc on the unit circle. we find the length of the arc on the unit circle. So let's talk about what an arc of a circle is. An arc of a circle is just a piece of a circle, right? So if I have an angle in, this is central position, I'm going to say central here instead of standard. It doesn't have to necessarily be in standard position, but it needs to be in central position. So it needs to be a central angle, all right? But an arc that an angle intercepts is the piece of the circle that's kind of separated by your initial and your terminal sides of your angle, right? And so a radian measure actually represents the arc that's intercepted on that circle, okay? So the radian measure is the length of the arc that's intercepted on your unit circle, all right? And so if this is our unit circle, then the length of this arc is going to be your radian measure, all right? That's just how radian measures are defined. And so one of the things that help us get to our radian measures and allow us to convert from radian measures to degree measures is answering this question here. It says, what is the length of an intercepted arc on the unit circle that represents one revolution, right? So we're talking about one revolution here. If we have our unit circle here, that means our center is here. Let's say that this is our initial side of our angle that is going to represent one revolution. Then our one revolution would be like this. And our radian measure is the length of the arc on the unit circle that's intercepted by that angle. Well, the length of that arc is this full circle here, right? So the length of the intercepted arc equals the distance basically around that full circle, right? Because one revolution represents full circle, and the distance around a complete circle is the circumference of the circle, right? This is the circumference. That's the circumference. The circumference of that circle is the length all the way around. And since this is our unit circle, we know that our radius is 1 for that circle. So one revolution, which is the length is 2 pi radians, basically. Now, we usually don't use the word radians as our units here. Radians are actually a unitless being or quantity, but it's 2 pi units, right? So one revolution in degrees is 360 degrees, and one revolution in radians is 2 pi, okay? And so since one revolution equals these two things in these different units, then we could come up with some conversion formulas to convert from degrees to radians and from radians to degrees. For instance, if I divided both sides by 2 pi, 2 goes into 360 180 times, then 1 is the exact same thing as pi, 180 over pi. I can do this the other way around and divide both sides by 360 degrees, and I'm going to get 1 equals pi over 180, right? So we use this formula to convert radians to degrees, and this formula here from degrees to radians. All right, we're going to look at this example here. For instance, let's go to part B. We have a 90-degree angle, right? So if I want to change this to, all right, we want to convert degrees to radians or radians to degrees, which is exactly what it's asking. So I guess I didn't need to have to write all of that. All right. But if I want to convert 90 degrees to radians, then what I could do is I want to go from degrees to radians. So I multiply by pi divided by 180, right? And so what happens here is that this degrees is still there. And so when I have this 90 degrees and this 180 degrees, the degrees that cancel because one is in the numerator and one is in the denominator, and then I'll be left with my radians here. So that's 90 pi over 180, which is the same thing as pi over 2. Okay, so 90 degrees is the same thing as pi over 2 when it's in radian units. We can go the other way around. Let's look at part C here. I have pi over 3. Well, I have my radian measure here. I'm going to multiply it, and then again, we don't use the word radians when we write it out, but this is like a degree measure here. And so if I multiply this, pi over 3 times 180 degrees over pi, our pi's will cancel, and I'm going to get 180 degrees over 3, which is 60 degrees. I want you to do part A on your own. You should see that this is pi over 6 in radians, and I want you to do this on your own, and I want you to see that that's 45 degrees. And so with these angle measures, I want you to be able to find all the angle measures in radian units for each of these angles here. I want you to do that and make sure that you can do those quickly, right? So this is pi over 6, pi over 4, pi over 3, and this is pi over 2, right? So we found that one, that one, that one, and that one in the previous example, right? Pi over 6 is 30 degrees, pi over 2 is 90 degrees, pi over 4 is 45 degrees, and 60 degrees is pi over 3 units. What you want to do is you want to find these other ones around our unit circle. What you're going to notice is that there are going to be multiples of these things here, right? For instance, 120 degrees is 2 times 160 degrees. So if I multiply this by 2, I'm going to get 2 pi over 3, right? Or 45 degrees, if I multiply that by 3, I'm going to get 135 degrees, right? And so that's going to be 3 pi over 4. This, if I multiply this by 5, I get 150 degrees. That's 5 pi over 6, right? So this is one way to get these quickly. And then 180 degrees is twice 90 degrees. So if I multiply that by 2, 180 degrees is the same thing as pi. And so you can do that here to get the rest of these angles here. But I'm just going to write these out. I want you to be able to convert these also. So go through the process until you're used to it of converting from radians to degrees. For instance, if I divide this by 30 and that by 30, I'm going to get 7 pi over 6. The degrees are going to cancel, right? 5 pi over 4, 4 pi over 3, 3 pi over 2, and so on and so forth. If I do 300 degrees, I multiply that by pi over 180. Our degrees cancel. That's 30 pi over 18. I want to simplify that even further. That's 5 pi over 3. I actually forgot about that, and because I forgot, I had to do it over. 7 pi over 4, 11 pi over 6. And this is 0 radians, or it's going to be 2 pi, right? If I do 360 degrees times pi over 180 degrees, 180 goes into 362 times, so that'll give you 2 pi, your degrees cancel, right? And so you have your full unit circle with the angles that you want to memorize. You have the degree measures and you have your radian measures. The last thing we want to talk about is arc length, right? Your arc length is a fraction of the circle, of the arc of a circle of radius r that's intersected by a central angle, which is measured in radians, right? So radians was the arc length of the intersected arc when your unit circle is your circle that you have your central angle in, right? But you can have the arc length of any circle, not just the unit circle of the radius 1. And that arc length formula is just something that you have to memorize, is r times theta, which is the radius of your circle, radius, times your radian measure of the angle. And so this example here says Peshtigo, Wisconsin is on the 45th parallel. This means that an arc from Prestigo to the North Pole subtends a central angle of 45 degrees, all right? There you go, 45th parallel. If the radius of the Earth is 3,950 miles, then how far is it from Prestigo to the North Pole, right? So, of course, we know that our Earth is a sphere, but it's on the 45th parallel. And so I'm just going to say that this is my North Pole here. And if I were to draw a 45-degree angle, all right, now a 45-degree angle will look something like this. I know that my Earth is 3,950 miles. It has a radius of 3,950 miles. So the distance from here to here is 3,950 miles. And the distance from here to here is also 3,950. We want to know how far it is from Prestigo to the North Pole. Well, it's basically this arc length here, right? So it's not a straight line distance. It's actually an arc length, right? It's a rounded distance. And when we have these rounded distances, we have to take into consideration the roundedness here. And so it is the arc length of that central angle that's intercepted by the circle. And so since our arc length, I'm going to use the variable s. I think that's what your textbook does. It's going to be the radius, which is 3950, times the radian measure of your angle. Well, your degree measure is 45 degrees. We found that that was pi over 4 radians. And so we have 3,950 miles times pi over 4 radians. Again, I said that we don't use the word radians. Radians are kind of a unitless measure. And so this is going to be 3,950 times pi over 4. And my units here is going to be miles because that's 3,950 miles times pi over 4 unitless objects. And so we multiply that, we're going to end up with miles as our units. And so that concludes this video. We'll see you during our next video.